Okay, so like I said, today's exponents, day 4. Really what we're focused on today are radicals, but as we learned yesterday, radicals are really just another way of expressing exponents. They're all kind of interchangeable. Okay, so number 1 is 100% review the square root of 75. When you are taking the square root of something and trying to simplify it, remember that your best goal is to look for a perfect square that's in here. What's a perfect square that's in here? 25. 25 times 3, so I get to pull out the square root of 25, which is 5, and I leave 3 on the inside. If you don't recognize that there is a perfect square in here, you keep going all the way down, and then you find the set of 2. Yes? Yes. Okay. With cube roots, things work almost exactly the same, except instead of finding sets of 2 or a perfect square, you're finding sets of 3 or a perfect cube. Okay? So 81 is 27 times 3. 81 is one of those powers that I want you to memorize. You need to know that 3 to the 4th is 81. It's going to help you out a lot. Okay? So at this point right here, I can stop because 27 is a perfect cube. What's the cube root of 27? 3. So 3 goes on the outside. And then the cube root of whatever's left, which is 3. Again, if you didn't see that, you would keep going. 9 times 3, 3 times 3. And then you found your set of 3. And that's what lets you pull one out. Okay? All right, so let's go ahead and write this next one down. The cube root of 80 times a to the 7th, b cubed. So we're going to go part by part. We're going to start by dealing with the square root of 80.
The cube root of 80?
Sorry, the cube root of 80. Okay, so let's think about that. The cube root of 80. What's a cube you see in 80? 8. 8 and 10. Are there any other cubes left in 10? No, because that would turn into 5 and 2. So what is the cube root of 8? 2. So I get to write 2 on the outside. And then the cube root of what is left on the inside? 10. All right, let's talk about the cube root of a to the 7th. Well, a to the 7th is a times a times a times a times a times a. Right? So remember, 1, 2, 3, 4, 5, 6. Yep, sorry, times a. So we're looking for sets of 3, right? How many groups of 3 are in here? 2. So from each group of 3, I get to pull out an a. So if I pull out an a times another a, what is that on the outside? A squared. And what's left over? Just a. All right. Last we have b cubed. Well, b cubed is just b times b times b. That's a set of 3 right there. So what gets to come out? B.
Do you get rid of that little thing right there?
Nope. Still the cube root. So this is 2a squared b times the cube root of 10a. Okay, now be careful. Do you see how I wrote this and it kind of looks like b cubed there?
Yeah.
It's better if you kind of like extend this out a little bit so it's really clear that that 3 is not part of the coefficient. That 3 instead is part of the radical. Okay? All right, let's try 4. Well, sorry, before we get to 4, let's kind of talk about these variables when we take different roots of them. Okay? Here's kind of what's happening, what you can think of mathematically. Say I had x to the 11th, and I wanted to take the cube root of it. Basically, if I wrote out 11 x's, you want to think, how many groups of 3 would you find? 3, because 3 goes into 11 3 times. So I would pull out x cubed. What would be left over?
1x.
3 goes into 11, and 3 times, that's 9. What's left over? 2. So that would be the cube root of x squared. So you divide and then see what the remainder is. So what if I asked you to find the 5th root of y to the 23rd power? Y to the 4th. Y cubed.
What's the rule to get that again?
So you divide the power by your index, and that whole number is what you take out, y to the 4th. It goes in evenly, 5 goes evenly into 23 4 times.
Okay.
Then the remainder, what's left over, is 3, so that's what's left under the radical.
Okay.
All right, let's look at 4. 3 times the 5th root of 64a squared b to the 9th. This time we're looking for 5th root, so we're looking for sets of 5. Okay? Yeah. Okay, so let's start by breaking down 64. And I agree that 64 is 32 times 2. Why did you go straight to 32? Good, because we know, or if you don't yet, you will very soon because you need to memorize them, that 2 to the 5th is 32. So on the outside, this 3 still just stays on the outside. So I'm also now going to have a 2 on the outside, and what's going to be left on the inside? 2. Okay? How about the 5th root of a squared? This 2 right here? This 2 right here? The 5th root of 32 is 2. So that's what gets pulled out.
Are you multiplying by 3?
You will, yes, because this 3 was already there. Okay, the 5th root of a squared, can that be simplified at all?
No.
No, so you just leave that under your radical. How about the 5th root of b to the 9th? Okay, 5 goes evenly into 9 how many times? Once. And then what's our remainder? Oh, sorry, b. Our remainder is 4. So this is b, and then b to the 4th. 3 times 2 is times b is 6b times the 5th root of 2a squared b to the 4th. Good. I like it. It's like a little puzzle.
I like math. When it's like this.
All right, look at the next one. The third root of the the third root of negative 54x to the 8th b. Am I allowed to take the cube root of negative 54?
No. Yes.
Yes. Why?
Because it's all
Good.
Oh.
You are allowed to take odd roots of negative numbers. Right? We talked about that yesterday. You are allowed to take odd roots of negative numbers.
Are we ever going to get to the point where it's squared into
So what would be the situation where you can't do it?
Like if this was a 4 right here, you would not be able to get a real number answer. So you wouldn't have that right now. You could say no real solution. Okay? All right. So negative 54, how does that break down? 27 and 2. Okay? 27 is 3 cubed. I'm going to go ahead and pull out the negative when I pull out the 3. So I'm going to have negative 3 times the cube root of, what's going to be left under the cube root? 2. How about x to the 8th?
X
go
squared
into
and
it
x
2
squared.
times.
3 goes in evenly to 8 twice, and the remainder is 2. And then what about this b?
Leave it.
Yep, I can't simplify that at all, so my b stays there. Questions on that? All right, go ahead and copy number 6 down. It's the cube root of negative c to the 5th over 125 d to the 12th. recommendation here is that we split the fraction and rewrite it the cube root of negative c to the 5th over the cube root of 125 d to the 12th. I'm going to rewrite this as the cube root negative c to the 5th over the cube root 125 to the 12th. Everyone okay with that? Split our radical. All right. The cube root of negative c to the 5th. Odd root, so I am allowed to do it. 3 goes in evenly to 5 once. So I pull out, I'm going to go ahead and pull out a negative c. Is that okay? All right. And then left we have the cube root of c squared.
How do you know if you can pull out a negative c or not?
It's just negative. Just like we did on the last one with the negative 27, we pulled out the negative.
Okay.
Over, what's the cube root of 125? And what's the cube root of d to the 12th? D to the 4th.
If we could simplify it, would we, like, if it was like,
Saying if this happened to be like c instead?
yeah.
Yeah, if you could simplify that, you would go ahead and do so. All right, look at number 7. Okay, what's different about number 7 than about the problems we've seen? Yeah, there's addition signs, okay? Remember, you're not allowed to distribute exponents or radicals over addition. So we have to try and turn this into something being multiplied, which is another way of saying we need to factor this. Okay? Remember, hopefully you remember that if you square any binomial, you get a squared plus 2ab plus b squared. So how does x squared plus 2xy plus y squared factor? X plus y squared. And I want the square root of that, which is just x plus y. So if you have something with variables and addition or subtraction signs, you have to try and factor it first. Only if it's a binomial squared will you end up being able to take the square root of it. Yeah?
How did you get x plus y squared?
Because I remembered the pattern of anytime you square a binomial. So do you see how these two patterns basically match? Okay, so that's a rule that you would want to learn. If you forgot that rule, you would just want to go ahead and factor this. Okay? Huh? You sure? Okay. Other questions? All right, look at number 8. 80 x to the 9th to the 1/4 power. What could I do first?
Make it the fourth root of it.
All right, so you could distribute your 1/4, or you could rewrite it as a 4th root. Since we're practicing radicals, I'm going to go ahead and do it like that. All right, go ahead and try and finish that problem for me. The 4th root of 80 x to the 9th. Start by breaking down. What are two things that multiply to give us 80?
8 and 10. Oh my god. There they
Yeah,
are.
you can just break it down.
So 20 times 4. 20 times 4. 20 times.
All right. So 80 is equal to 16 times 5, and 16 is the fourth root. But if that doesn't jump out at you, just keep breaking it down. And then find a set of 4 if you can. Okay? So I would pull out a 2. I would get the fourth root of, I would have a 5 left inside. The fourth root of x to the ninth. So 4 goes in evenly to 9, x 2 times. So that's x squared. And then left over I have an x. Questions on that?
16 plus 5. Oh, no, no, equal 80. 8 minus 4.
Okay. Let's look at number 9. 3 times the fourth root of 7 minus 5 times the fourth root of 7. You are allowed to add and subtract radicals as long as the radicand is the same, the number inside the radical. And now that we're dealing with these like third roots, fourth roots, fifth roots, that index has to be the same. So the root that you are taking has to be the same. So because the fourth root of 7 here is exactly the same, we can go ahead and subtract. 3 minus 5 is negative 2. And then you keep your like term, the fourth root of 7. Questions on that? You like that one? Okay. Try number 10. 8 root 15 plus 7 times the cube root of 21 plus 12 root 15 minus 4 times the cube root of 21. Only combine if they are exactly the same radicals. Same index, same radicand. Yeah, that's a cube root.
Can we like switch them to a cube root? Like if it's a square root, you like make it, we'll like unsimplify it and like resimplify it.
Only if it can be, because we can't do that without applying an operation to the problem. You're not allowed to do that because there's no equals. Okay, so I can combine 8 root 15 and 12 root 15. Gives me 20 root 15. And then I can combine 7 root times the cube root of 21 and negative 4 times the cube root of 21. That's going to give me 3 times the cube root of 21. That's as far as you can go. The only other thing you would be able to do is if the square root of 15 or the cube root of 21 simplified, you would need to simplify those. Okay? All right, try number 11, please. What are you going to have to do?
Simplify.
Yeah, you're going to have to simplify each radical and then see if any of them can be added together. So break down each radical.
No.
Oh.
That would be.
It was really bad.
Never mind, I got this thing.
Austin has
Oh my god.
Your face is like.
Okay, I'll restart Negative 5 right I did. Is that what you guys got?
Okay, good job, guys. How did 5 root 50 simplify? Good. Minus what? 6 root 2. Plus what? 36 root 2. So you should have gotten 55 root 2. Any questions about that? Okay. We're skipping 11 and 12, so you can number this 11 if you want. Don't feel like you have to write all this. You can just draw the rectangle. That's 12. You can draw... So it's asking us for the perimeter. Okay? What are we going to have to do in order to find the perimeter? Yeah, Pythagorean theorem to find the missing side. So 5 squared plus x squared equals 121, or sorry, 11 squared. 5 squared is 25 plus x squared equals 121. Right? But this makes a right triangle, half the rectangle. Okay. What is 121 minus 25? So x squared equals 96. So x equals the square root of 96. It's not going to be plus or minus because this is a figure. 96, what does that break down into? 32 and 3. And then 32 breaks down into 16 and 2. Well, 16 is a perfect square. So it would be 4 root 6. Okay? So that means that this width down here is also 4 root 6. And this length is 5. So if I want to find the perimeter, what would it be?
8
Inches. Very good. Okay? All right. Using the formula for volume of a sphere, we want to express the radius in terms of its volume. Okay? What that means, express the radius in terms of the volume. You're trying to solve for r. You're still going to have a variable left in your answer. It's going to be a v. It's going to be your volume. So, the formula for volume of a sphere, does anyone remember? 4
Oh,
thirds
of r cubed. Pi r cubed.
pi r cubed. Good. Express the radius in terms of the volume. So our goal is to solve for r. So how would I get rid of this 4 thirds? Multiply by 3/4. This is 3/4 v equals pi r cubed. So that's how you cancel out 4 thirds. Yeah, if you want to do it in 2 steps, multiply by 3, divide by 4, that's fine. What would we do next? Divide by pi. Dividing by pi is the same as what? Good. So this would become, could I write this as 3v over 4 pi? Right, because it's like v over 1. So 3v over 4 pi is equal to r cubed. What would we do next? Cube root, which means that r is equal to what? Good. All right. So suppose you are given a sphere with a volume of 64 pi centimeters cubed.
Oh, that's the answer.
Yeah, this is the answer of the first part because we have radius in terms of volume because it's a variable with volume over here. Okay, so we're given a volume and we want to solve for radius. So I'm not going to go back up to this formula because that's a waste of time. I already have my radius isolated over here. So I know that my radius is the cube root of 3 times 64 pi over 4 pi. Ideas for simplifying this. What is what? What is the radius, I think it says, of the container? Hold on, let me look. Yeah, container. Basically, what's the radius of the sphere? That's what the question asks. Okay, so what can we do with our pi's? Cancel them. And then I don't really want to multiply 3 times 64. But can't I reduce 64 and 4? Yeah, how many times is 4 going to 64? 16. So this becomes the cube root of, what's 3 times 16? 48. So let's see if we can simplify the cube root of 16. Sorry, yeah, the cube root of 48. What's a cube that we know goes into that? 8, good. It's 8 times 6. What's the cube root of 8? So this is 2 times the cube root of 6 centimeters.